All right, guys, AKDC Revisited. It's transformation once again. Second, I believe, of three different times we're going to see it in this course. You'll see it next year also. So AK and DC are transformations, and we're going to transform a exponential function. Now, when we transform functions in the past, they were either y equals x, 1 over x, x squared, or root x. So those were our base functions. These, in this case, we don't really have a base function. We have a function and then we're going to modify it. So in this case, the one we did in class was y equals 3 to the x. And we can see what that looks like. Give me 1 second here. So this is y equals 3 to the x here on Desmos. Key parts here, key points is that at 0, x equals 0, I cross at 1. So that's my a. And I'm growing at a factor of 3. So at 1, I'm 3 times bigger here. So my ratio is 3. I go to 1, 3. And then the next point would be 2, 9, which you can't quite see here. So now we're going to modify this by adding and subtracting and multiplying and dividing with the help of AK and DC. So, but let's go to our base function. Our base function is 3 to the x. So we're going to move this. So first we have to know the key points here. And let's start with, I'm not going to do all the ones we did in class. You know what, I'll do them but I won't modify all of them. So if you start with -2 for your x, and then -1, and then 0, and then 1, and then 2, and then I'll add 1 here, 3. Okay, so now we're just going to find out what 3 to the 3 is. 3 to the 3 is 27. 3 squared is 9. 3 to the 1 is 3. 3 to the 0 is 1. 3 to the -1 is 1 over 3. And 1 over 3 squared is the same as 3 to the -2, which is 1/9. So we're going to modify these points. So we haven't, I don't have an equation here yet, but the one we did in class was this one. So I take this and I'm going to change it to this. Minus 3. I get a 0.5 up here, bracket. So remember, we need the bracket between the k and the x here. So if there's no bracket, you need to divide out. And then it happens to be a 3 again on the outside. So let's go through all our values and see what that does to these points. Here I have A. A is what's in front of. So remember that A and C are on the function. These are the vertical. K and D are on the x. So what's on the function? You start off with this thing first, and it's a is equal to negative. You see negative, and what's that mean? That's -1. Okay, so that's a -1. K is 0.5, and we'll figure out what that means in a second. D is 2. Remember, change that sign. Horizontal stuff is opposite. You'll see in a second. And then your C is +3 or just 3. So what does this all mean? That means I'm going to flip this, and if it's remember, this is vertical, this is vertical. So I'm going to flip. If I flip vertically, I'd flip in the x-axis, or go back to your parabola. Remember, if we put a negative in front of the parabola, I'd flip the parabola like this, right? Reflected in the y-axis. So also, this affects y, this affects y, this affects x, this affects x. A little pattern to that. So this is going to be a vertical flip, or multiply y by -1. So I'm only going to do a couple points. I'll do, I don't know, let me just do this one and this one. And we'll follow these through, and then you can follow the other ones later. So take your a and multiply by -1, or sorry, your y and multiply by -1. So that's -2, -1/9. And then here I have 0 and -1. And you do the same for all of them. K here is a 0.5. And remember, that is a 0.5. It's less than 1. And when it comes to K, it comes to horizontal, that's a vertical stretch. So this was a reflection in the x-axis. This one here is a horizontal stretch of 2. Horizontal is on the x, which means I multiply this by 2. So I multiply all my x values by 2. So they're all twice as big. So -2 becomes -4, and 0 times 0 times 2 stays at 0. So that's where I am here at this point. D means move. D of -2 means right 2, which means add 2 to the x value. So -4 plus 2 is -2. And 0 plus 2 is 2. So there we go with those. And the last one, I'm going to affect the y's here by moving up 3 or adding 3 to my y's. And that is going to be a little tricky. Decimals and fractions are going to play a role here. So -1 plus 3 is 2. I have -1/9. If I add 2 to that, I'm 1 less than add 3 to that, I'm 1 less than 3, 1/9 less than 3. So one way to write that is 2 8/9. Okay, you could also get the common denominators and figure that out. Okay, and then I'm going to plot those points. And when I do that, and you can start thinking about what's happening here. I have a reflection. I am compressed. I moved right 2, and I'm up 3. So that's a hard thing to do, conceptualize. But if I did have that, let me just put this in here in a different color. So we got -3 to the power of, and I'm just going to pause this, but I won't. I'll just mumble as I move through this. 0.5 bracket, x minus 2, close your bracket, and then move this down and add 3, and it should look something like this. Now, does that make sense to you? I don't know if it does. Let's see if it makes sense to me. First of all, let's zoom out and figure out what's going on here. So let's go over this. What's going on here? Is that right? Well, I've taken this and I've moved up 3. So instead of being down here, so first of all, I flipped it. So if I flip it, it's going to look like this, right? It's going to come down here. And after that, I've taken it and I've horizontally compressed it by, horizontally stretched it. So I pulled it out and then I moved it up 3 and I moved it right 2. Now, if you can make sense of that, you're a better imaginer than I am. But that's what it ends up looking like. So that's why we don't try to graph this like this. You can graph it a different way, which is the next part of this part 2 of transformations. But the way we just did it is consistent with our old AKDC. Okay, move the points, figure out what A is, what K is, what D is, what C is. Move the points, you move the points, you move the graph. You move the graph, you move the world. I guess I don't know. That's kind of deep. Okay, have a nice day and take care.